Hello, this is question 10 from the 2019 Cambridge International Education Exams. It's from the winter set of exams, paper 1-2. Now it's a pretty big question split into 3 parts. Each part is probably as difficult as the other. It's about differentiation and integration of this curve here and that intersects with a line. You can find a link to an image of this question in the description below. Here's my attempt to draw the question. I hope that's just about good enough and you can see the equation here. Part 1 asks us about this equation. It asks us to differentiate it and to integrate it. So let's just do one at a time. Now let me rewrite that down here, but I'll take the opportunity to write it a little differently. Y is equal to 1 minus and 4. I'll keep all that the same. But this bracket down here, I'm going to put that up on the top row. And you can always do this, instead of to the power of 2 on the bottom, it's the power of minus 2 on the top. That's all the minus does, it brings it above or below the bracket. That's just going to make it a little easier for me to differentiate and integrate. You don't have to do that, but it makes it a little easier for me personally. Okay, so let's differentiate first. dy dx equals, just each term, there's 2 terms, here's one, here's another term. So the derivative of 1 is easy, it's nothing. So let's move on to this. Let's do it in part. It's going to be a chain rule. So let's start with the minus is a minus, the 4 is a 4, they're constants. And now we're left with this complicated term. Let's pretend it's one simple term and we'll differentiate this simple term. We get minus 2, that comes down, and we take 1 away from it and we leave this here alone, 2x. But that's not quite allowed. That's sort of cheating. We use the chain. It's not cheating. It's the chain rule. We ignored this term, so now we better deal with it. Let's differentiate it now, and the derivative of this is just 2, and that's it. That's the derivative. But I can clean all this up. I think we have 2 times 4 is 16. We have a minus and a minus, so we get 16 plus 16. Times this bracket, and instead of writing this bracket like this, it's a minus 3, so let's put it back where it probably should be. Although, honestly, like this is fine to leave it on the top row with the minus, but often we write it on the bottom row like that. So that's the answer there. Right, let's, I think I'll have room to do the integral, I should say, I'm sorry. So that's what they mean with this, the integral of y with respect to x, that's how we read that. And again, I'll use this y here. So this is equal to the integral of 1 minus 4 2x plus 1. And the integral of 1 is a bit is more difficult than the derivative. This is equal to x. And then we'll have to do this guy separately. Let's go minus 4. The constant, don't care about it, so I'll take it out. And the integral of 2x plus 1 to the power of minus 2. Or I guess a lot of people would rather this on the bottom row. It doesn't really matter. The point is, this is a bit difficult to do. Some students are okay at doing this in their head. I think if you held a gun to my head, I'd probably get it right, but I might be off by a factor of 2 or a factor of 4, actually, more likely. So what I'm going to do is, I'm going to do this guy separately. So how about I rub out what's here? That's our answer for part 1. I hope you have that. Let me rub this out, and I'm going to do an aside to the question. I'd often do this in an exam. If you're going down a page in an exam, I'd often be answering like this, and then sometimes I do a little aside here. Just a question that doesn't really fit. And instead of doing all this in one line, I'm just going to take to the side and do this sub-question. Actually, how about I write it like this? I think people will be happier. 2x plus 1 to the power of 2. Again, this is still the question we're doing, but this is inside it. And it's a big enough part that I think I'll just do it over to the side so this doesn't get too messy. Now, this is too difficult for me to do. Like I said, some people can do it with a rule in your head. It's sort of like backwards differentiation. You ask yourself, what term must you have had to get this when you differentiate? That's what a lot of people do in their head. You don't have to do it in your head though. How we can do this is we substitute. I'll choose to substitute what's on the bottom row here. I'll put this as u is equal to 2x plus 1. That's what I'm going to use as a substitute. So instead of this question, I guess I'll be doing, I'm going to run out of room if I do write this too much, but I'm going to be doing the integral du. The problem with, sorry, not u there, 1 divided by u squared. The problem with this is we can't integrate u with respect to x. We need du here. So that's easy enough to get. We just differentiate du dx is equal, let's say that's just 2. Now we have a u and an x. How about we rearrange this? Dx can come up here, and the 2 can come down here. Du is equal, du over 2 is equal dx. Right, let's replace this guy then. Instead of dx, let's write du divided by 2. So this is equal the integral of 1 over u squared du, and the 2 can fit in down there. Now this is something we can do. We can integrate this. Let me write it one more time. 1 over 2, or half, now we can just ignore that, of u to the power of minus 2 du. This integral, I don't think I had quite enough room to do this. This integral is not too bad. We ignore the half can stay outside. We add 1 to this number, and we get u to the minus 1. And then we divide by the new number, minus 1. So we divide by minus 1. It's like multiplying by minus 1. That is the derivative, the integral of this plus some constant, of course. And instead of u, let me continue this on here, I guess. Instead of u, we know what u is. It's this. So this all becomes minus 1. The bottom row has a 2 in it. There's a u on the bottom row. That's what minus 1 means. It's on the bottom row. 2x plus 1. That's a perfectly fine way to leave the answer. We can multiply the 2 in if you'd rather, but I think I'd leave 2x plus 1 because it's going to appear all over the place. So that's the integral of this. So in that case, this whole answer becomes x, sorry, there's a plus c here still, x minus 4, and the integral of this we now know is 1 divided by, let's see, it's minus, so, well, let me just write it like this, minus a half 1 over 2x plus 1. We can clean this up here again. We get x, 2 divides into this, the minuses become a plus. We get 2 divided by 2x plus 1. This has a constant, sorry, this guy here had a constant, but so does the x. So maybe I'll call this guy C1. This guy could have had a C2 if you wanted. Ultimately, there's some constant left over. Constant here plus a constant there makes another constant. So that's the integral of that. I hope that was clear. I apologize for going a little unorganized, but there's not quite that much room on the board. Alright, let me rub this out and we'll do part 2. Okay, in part 2, they're asking us to find the coordinates of B. So this was tricky for a lot of students because they didn't know where to start. And how we start is we have to look at A, we have to look at this line here. They tell us this line is the normal. First of all, the normal, that means it's perpendicular to the tangent, is what that line is. So how we have to do this, we have to find A first, find the slope of the curve at A, get the perpendicular of that slope. So now we'd have a point A and the slope of this line here. That means we can get the equation of this line. The equation of this line will give us the point B. So that is how we find the coordinates of B. So let's start that. Let's find A first of all. What do we know about A? We know y is equal to 0 at A. So we know 0 is equal to 1 minus 4 over 2x plus 1 squared. Let's add this term to both sides. We'll get 4 divided by 2x plus 1 squared is equal to 1. Let's multiply this both sides by this guy. We'll get 4 is equal to 2x plus 1 squared. Let's get the square root of both sides. So we'll get 2 or plus and minus 2. This could be a plus or a minus, could have squared itself to get 4 is equal to 2x plus 1. So let's solve for our 2x. 2x is equal, let's go with plus first, because there's two numbers here, there's a plus or a minus. Let's pretend it's a plus first, so 2x equals 2, and we take this away from both sides. minus 1, 2x is equal 1, x is equal a half. Another possibility here was the fact that 2x was equal to minus 2, and then let's take 1 away from both sides. X is equal minus 3 over 2. Now, good thing is we know this one's not true. Why do we know that? Because they showed us a picture. They showed us a picture and it's clearly not on that side. Did they tell us x? They don't write that in maths, they just tell us in the picture, unless I don't see it there. So this one's not the answer. The answer is a half. A is, let's put it down here. A is a half 0. That's the coordinates of A. Now we still need to get the tangent, the slope at A. That's okay because we have the derivative from earlier. We have dy dx is equal to 16 divided by 2x plus 1 to the power of 3. So we have that from earlier. And to find the slope, we just need to know what x is. And we know what x is. dy dx when x is equal to a half is equal to 16. 2 times a half is 1 plus 1 cubed. That's equal, let's see, 16 divided by 2 to the power of 3. That's 16 divided by 8, which is equal to 2. So the slope at this point here is 2. So what about the slope of AB? So let's say MAB. That must be equal to the inverse of this. So that's minus a half. You often just say turn it upside down and change the sign. It's really two slopes multiplied to get minus 1, and then that must be minus a half here. Okay, so let's find the equation of AB. That's y minus y1, and we need a point on it, so we'll take this guy here. y1 is 0 equals, let me think, m minus, I'm forgetting here, minus a half multiplied by x minus x1, which is a half here. That's the equation. We can clean it up a little. I like to leave it mostly like this. Y equals I like, minus a half x, I like that separate. And I'll multiply this in, so I get plus a quarter. Now one reason I like to leave it like this is it gives me lots of information. In this case, one of the pieces of information is the y-intercept, which is right here. So now tells me that that is actually a quarter. So I have b, I guess. And b must be 0. We knew that from the picture. We know it's 0, and a quarter, because that's the y-intercept. So that's part 2. None of the maths was difficult in part 2. It's just it took a long time to get there. Right, let me rub this out again, and we'll do part 3. Okay, part 3 asks us to find the area of the shaded region. I haven't shaded it, so I better do that now, and all the way up into there. Now, I cannot do all that in one go, but what I can do is I can do this triangle. That's quite easy, that little triangle up there. It's a half long and it's a quarter high. So we can work out the area of that. It's 1 over 16. 1 over 16 is the area of that. But then so that leaves me just to do this more complicated little one. It goes this, and it actually goes on forever. It goes on into infinity all the way down forever there. But we can get the area of it. All we need to do is integrate the curve, and we've already done that. We can find dy dx. Luckily, we've done this in part 1, and all we need to do is go between 2 points. So we need to go from 0 to a half. Now that'll actually give us a minus answer, because it's below the curve. So if you'd rather, we could go from half to 0 to get a positive answer. But honestly, I don't think it really matters. Just at the end, we're doing one simple segment. So at the end, we can just say, right, it must be a positive. We're getting an area. But I'll just do it correctly here. I'll go from a half to 0, which will give me positive below the line. And this is equal to x plus 2 divided by 2x plus 1. and this is, let's put a little thing around it like this. This is between a half and 0. So how do we get this? We put 0 in, and 0 will go in, well, let's do it here. 0 goes in 0 plus 2 divided by 1, so plus 2, and then minus, we put this guy in, we get a half, and then minus a plus, we get 2 divided by 2 halves is 1, 2 divided by 2, which is 1. So let's work all that out. That is equal to 2 minus 1 is 1, minus a half is a half. So the area of this guy here is a half. Not our final answer, we still have to add these together. Now I never did this sum here. It's a half multiplied by the height multiplied by the base, which all equals 1 over 16. So the final answer is 1/2 plus 1/16. So many students are terrible at fractions, and let a calculator do it if you want, but I'll just, instead of 2, I would like 16. So I just changed this guy to a 16. I must have multiplied by 8 to get there, so I better multiply the top by 8 as well. And that 8 plus 1 is simply 9 then. 9 over 16. 9/16 is the total area of this this shape, and which is cool because it goes on for an infinite. It's infinitely big, but somehow it has a finite and quite small area. Alright, I hope I answered some of those questions for you. If you have any follow-up questions, I had to go fairly fast. It was a big question with a lot of information in it. So if you do have any questions, put them in the comments below and I'll do my best to answer them.